Hey, there we go. Welcome back to the live stream. My name is Jeff Fritz. Thank you so much, everybody, for joining us. And I've got a special guest today because we're going to be talking to our friend Jeremy Norman from RayGun. Hey, Jeremy, thanks so much for joining us.
Yeah, hey, Jeff. How's it going? It's great to be here. Thank you.
Thanks so much for joining us. We've got a bunch of friends in the chat room. I see M. Holloway24 out there. Great to see you. And Dee Dee Walsh is here from Bellevue. Bellevue is a city, not a mental hospital, she reminds us. Thanks, Dee Dee. Thanks. We appreciate you letting us know about that. So, Jeremy, RayGun. Gosh, what kind of things do you do over at RayGun? And can you give us a little intro about yourself here?
Yeah, certainly. So I'm the CTO of RayGun. I've been in that position for about 6 months, taking over the reins from the very capable co-founder, Jeremy Boyd. So my role is really about managing the technology of RayGun and ensuring that we're using the right tools in our application and that the infrastructure and everything is just humming along and that we're able to scale and deliver a great service for the lots of the customers that we have.
Now, it's not a requirement for that job to be named Jeremy since you took over for Jeremy. That's not a thing.
I did,
right?
Yeah. No, it's not, but we have had a few Jeremys. I think at one point we had 3 even, and we're looking at hiring a 4th. So
oh my gosh.
It was getting a little bit confusing for a point there, but we're back to 2. Back to 2 Jeremys.
Okay.
It's definitely bonus marks if your name starts with a J. So we've got like a John Daniel was the other co-founder.
I've got an opportunity.
And, a few Jasons. Jeff, yeah.
Okay. Oh my gosh.
And RayGun is hiring at the moment. So if your name starts with a J, you've got that first box ticked.
Let me write this down. There we go. All right.
After live stream, go hire.
After the stream, go apply to RayGun.
Go apply for RayGun.
There you go. Oh my gosh. But RayGun's known for doing application monitoring, crash analysis, crash reporting. And our friend Clinton Rock Smith here in the chat room says that they use RayGun as is that Scadulo? Let me know.
Right.
That's awesome.
See a customer online.
Yeah, right. So But there's new features, there's new applications, there's new capabilities that you guys are working on and that you're building, and gosh, making sure that your own stuff is up and running. You must learn a lot, almost like dog fooding, right? Making sure your applications work with RayGun.
That's right, and that's how we develop our products. Everything that we've developed, we dog food ourselves. So RayGun, when you're using the app.raygun.com or even the RayGun public website or the blog or anything like that, RayGun is actually sitting in behind those websites and applications and is monitoring RayGun itself. We definitely use all our own tools, and as we'll show later on in the live stream, we've got some great examples of things where because of our tools we found some really interesting things that we wouldn't have even assumed were a problem.
And that's the best testament to the strength of a product, when you're able to use your own product to either build it or on some other project that you're working on. And look, we figured out how to improve this, and because we use our own products, right?
That's right. Yeah. As a developer, the tools really help, and we're writing tools for developers, so we need to be using these tools ourselves. So we do, and we get great use out of them.
I always thought it was. Go ahead.
It's just, I guess, what really is that aha moment where you're developing a tool, and if it's solving problems for you, that you're gonna it's gonna be successful, and you're gonna other people are gonna love it. So,
I always thought it was weird when the folks told me that that they use C# the C# compiler to build C#, right? It's like, how's that work, right? Or Visual Studio to build Visual Studio. You had to use Notepad here at some point, right? There's a chicken and egg thing that happens.
That's right. Yeah.
So, Raphael DCA in the chat room says that they use RayGun at Raphael's company as well. Well, thank you, Raphael, for sharing. Yeah, we're gonna take a look at some samples here and see how we can use RayGun a little bit better. Should we go over to your screen, Jeremy, and take a look at?
Yeah, we can do that. So I guess we're going to run through a few things today. I guess the focus really is around the new product that we've built, APM. So that's Application Performance Monitoring, which is monitoring the performance of your server-side application. So if you've got a web service or a web backend, a standard ASP.NET MVC web application, then monitoring how that's performing on your server. So that's really the focus of that tool.
Cool.
At the moment, we support .NET and .NET Core, and we're developing support for other languages at the moment. So working on Ruby and Node, along with PHP and Java coming later.
I don't know about PHP, but Node, definitely. That's one that folks should be interested in. Absolutely. I'm going to cut over now to your code, to your screen. There we go. We can see it there behind us.
Yeah. So the other thing I thought, I don't know who's tuning in, so what we'll do is go through a bit of a setup process of APM to start with. But I thought it may be interesting just to set up the other applications as well, since they're fairly quick to do, and it sort of gives you a complete picture of how all of the products.
Well, let's ask the folks in the chat room, and drop a 1 in the chat room if you've used RayGun before, or if you're currently using it as part of a deployment that you have for your application, for your organization. Let's let Jeremy know, that you're interested and you're using RayGun. It's Boke, and we already heard Clinton Rock Smith is using it, and Raphael. So we've got a couple folks here that are using it. There's a little bit of lag because of how long it takes to deploy things. Oh, Clinton uses it with Xamarin. Okay, so mobile applications they can also use RayGun with.
Yes, definitely. So I guess the two products that we had before APM were crash reporting and real user monitoring, and both of those are applications or tools that you can use in mobile and web applications, even desktop applications.
Okay. Yeah. Snoopaloopy says this is the first time that they're hearing about it. Jeremy was showing me some of the screens yesterday, and the detection and some of the suggestions it was offering, I'm like, oh my gosh, I wish I had this.
Yeah.
So yeah, debug WriteLine for performance monitoring. I agree, Stelzy. That's not the best. Okay,
Not
so
the best. That's not going to work too well for you in production. That's probably great when you're working locally.
yeah, yeah. So there you go. There's a link if you want to try RayGun for free in the chat room. Okay, so you wanted to show us the applications.
Yeah, so I'll just go through what it's like to actually set up RayGun. So the first thing that I've done here is I've created a new application. So I'm going to use the eShop on Web Microsoft application, which you can download from GitHub.
It's right there.
So that's available at .NET Architecture eShop on Web. So yeah, go and download that. It's a great little .NET Core application if you want to just download something and get playing.
A couple nice.
Use that.
Yeah, there's a couple nice books around that website that show you how to do different things with architecture and containers, these types of things.
Yep. So the first thing you do with APM is this is the first product where you need an agent running on your machine. So with crash reporting and real user monitoring, those were more let's reference a package or let's insert a code snippet and immediately as you deploy your application, those are now integrated. But APM works slightly differently in that you don't actually need to put anything into your code. You can install and get APM up and running without any code changes. But what it does require is for you to install an agent on the machine, on the server, to capture the profiling information.
So, yep. Let me make sure, right? No changes to my application. It just knows we're going to teach it how to find the application, how to attach to it, and start monitoring it. I can deliver the same crummy code that my developers that I wrote into that production space. Yeah, I just have to put a service down on that machine. Now, that could be a little tricky if I'm talking about a cloud environment, whether it's AWS or Azure, right?
Yeah, that's right. We do have a solution for Azure Web Apps, or so with their it's PaaS, isn't it? So,
yeah, the PaaS, the platform as a service.
Platform as a service. You're kind of limited in what you can install on those environments. So we have a RayGun APM extension, which is you go into the Azure interface, you go down to extensions, type in RayGun APM, and it's usually near the top.
Nice.
And click install, and it will behind the scenes download all the pieces that are needed for profiling your application in a Azure app service.
Cool.
So this is coming from a scenario where you've actually got access to the desktop. This can all be scripted as well. So we have examples online about how to completely script this using PowerShell or whatever scripting language you want to use. Because a lot of people will be using infrastructure as code. You're creating your infrastructure all automatically, and you can integrate the installer or downloading the installer as part of your sort of startup script.
Now, Jeremy, Stelzy has a good question here that follows up with that. Can we attach that to a Docker deployment as well?
Yeah, definitely. Docker, containers, it's just a matter of adding in the RayGun agent into your Docker configuration.
Yeah, into your build script. Okay.
Into your build script, or just running the script as part of that build. So it's something that we do need to probably document a bit better. And definitely keen to, because I use Docker myself.
Cool.
Yeah. So I'll start this up. It's a fairly simple process. It's literally next. So basic installer, which is why you can automate this. You can just execute this in a silent installer, and we're done. So
nice.
We've now got all of the components to start profiling an application. So what we've got now is we've got an agent that's running as a Windows service. So it's going to be collecting the information, and it's installed all of the requirement profiler DLLs and things like that onto the machine. Now, this is a GUI configuration tool. I'm not going to use that because we're all developers and we use command lines, don't we?
Yes, we are elite developers here. We know
Elite
how.
developers, yeah. No, I use that tool all the time. But what I wanted to show, because the common scenario is people are scripting this, so I'll show you from a scripted process.
It makes perfect sense to be able to script that.
Yeah, the other thing that we do, is we install a command line tool onto the, as part of the install, and the install commands are all documented on our website. So I've just got 3 commands here, which I've pre-prepared.
Okay.
The first one is I need to register the agent. So what I'm doing here is I'm saying, hey, RayGun, here's my agent. Is this API key valid? Let me send some data. So we'll register that. Our agent is now registered. The next thing I want to do is I've got the eShop on web DLL that I want to sort of tell the agent to, I want it to make it aware of my application now. So what I'm saying is, let's enable profiling of the output of eShop on web is just web.dll. Very, very innovative name that they have got there.
Makes it easy to find.
It does, yeah. And we're just going to say that this is a .NET Core application. Okay. So, if you're not profiling .NET Core, you may be doing full framework. That parameter would be slightly different.
Okay.
I've got my API key, and I've got a couple of extra parameters just to say don't recycle my process. It's not actually running at the moment, but I just want to leave it running.
Okay.
I realize that I've put my API key in here and everyone can see it, but after this demo, that API key is going to be going away. So you've got a limited amount of time for those people watching. So now I've told the profiler that, hey, I've got this application.
Cool.
So now I'm actually going to, there's many ways that you can start an application in the .NET space. So one is just, .NET run my web application.
Sure.
You can host it within IIS now with their hosting module. But in order to profile, we need to give that application, we need to set it up with some environment information so that the CLR knows to attach a profiler. So this is something built into the .NET framework, or the CLR is that ability to profile an application. So we've created a little sort of bootstrapping process here where I want to say to the, using my command line tool, run my web DLL, and it will automatically go and configure my profiler for me. Again, we have this documented online and with about the 3 or 4 different variations about how you'd actually do that.
Now, it's a good thing you've actually got the text there a little bit small, so folks can't see all of it too well if they're on a phone or something like that, and that's okay. What I am seeing just above me there is the bottom few lines of it look like what I expect and I would see out of that ASP.NET Kestrel web server. Now listening on, application started, the hosting environment, those last 6 lines, I know those lines, that's the web server. But I'm guessing the stuff above that's RayGun starting up and saying, here, let me get my agent running, here's the application to attach to.
Yeah, so that's right. It's that command. We've set up some environment variables, so that we've output these onto the screen, literally so that you could copy and paste these into another command line and you get the same output. So
okay,
it's applying what's called environment variables here.
Okay.
So the existence of these environment variables are what tell the core CLR to what to attach as a profiler. And then this is just showing you where the actual profiler DLL exists on this machine.
Cool.
Yeah, so now when we go to our local host, 5001 on HTTPS, we should now have the eShop running.
There it is. All right, that's the sample storefront application that the Microsoft folks have built. Okay. Looks just like we'd expect. Yep.
So I can hopefully interact with this. Yeah, here we go. I can do some things. It's I really like this black t-shirt. I like this logo actually. Is that the same one that you had on your intro, or?
Kind of. I've
it
adapted a little bit because the eyes in that one are a little in beady. So I made. We actually opened it up, and some of the folks in the chat room there, they've got those emotes, and they can drop it in. I have one where he's got sunglasses on, some where he's angry, and he's got a shield. Another one where he's attacking. There it goes. Goes flying by in the middle of the screen there. So
yeah. So I want to buy 12 of these because I'm a generous person, and I want to buy them for all of my team. So let's buy a few more than just one. Be selfish just to purchase one for myself, wouldn't it?
There they go. The chat room's chiming in and sharing some of those emotes. Cool.
Great. So we've purchased. Now let's go back to our application. And I'm not sure if you noticed before, but this was sitting on a screen where it was like, here's how you set up RayGun, here's your API key.
Yeah.
So,
wow.
And it had a little thing sort of sitting up in the corner saying, hey, we're waiting for your data. Now, it's detected that we've sent some data. So that's just the process of me installing the agent, registering it, started up this application with that API key, and I've, clicked around a few things, done a few actions on the website. So now we've started receiving some trace information. So we can see the process that we went through here. I went to the basket, I updated the basket, I logged in because I wasn't logged in. So there was a get there and a post, and then I did a checkout.
All the things that you would see in that ugly text file that the web server's recording, but those are hyperlinks. We can get more information out of it, can't we?
We can. So what these are traces of what happened on the server for each of those. So what I've noticed is this application is fairly basic, but we can see here some of the things that are occurring, and that how they've developed this application is, it uses async await patterns a lot, which is allowing your application to do things over multiple threads without blocking a thread whilst doing, say, a database call. So what we've actually detected here is you can see that there are a number of threads being executed in this request. And we can collapse that up, and we can see there was a database call, quite a few database calls going on in this to my local host eShop on web catalog database. Go and collect some information.
Giving me all the SQL statements right there. My gosh.
That's right. So that's all just been detected as by the agent running on attaching to your application. We're not doing any database profiling or anything here, so it's not connecting to your database. It's not monitoring your database. It's just monitoring the application and what the application is doing.
Now, this feels like something where if I'm not behaving well as a developer, and I'm not querying the database well, right? And there's a number of very well-known patterns that people could be abusing their database, and database administrators love to criticize me for. This has got to be able to pick up and recognize some of those patterns too, right?
Yeah, that's right, and thanks for asking that. So
this is serving up that meatball so you can hit it out of the park there.
Yeah. When we developed APM, we thought, what are the sort of things that as a developer, you're working on software, you're just writing the code, but what are the sort of common problems that developers accidentally introduce into their software just by writing code?
Yeah.
So what we did when we developed APM was really think about that. And so this application is a really well-written, high-performing application. So I've got no issues here.
Right.
But what we've got is a concept of issues, where as we start seeing the information coming in from your application as it's been profiled, we'll start analyzing that and raising issues that are things that you can try and fix immediately. So I'll just switch to some other data So this is now looking at, so that's not the greatest one.
While you're bringing that up, I want to say hello to some of the new folks that just joined us. How's it going there, Nibro and Svava? What mischief? Good to see you. Thanks for tuning in there in the chat room. Now, this said sales demo, but is this really a sales demo?
I would hope not.
Okay.
Yeah, so I'm going to show you some quite interesting technical things that we have solved with RayGun. So
there's a question in the chat room that I think you just showed us, but I want to call back to. Nibro7778 asks, does APM tell us how much time your query is taking? And you were just down in that area.
It does. Yeah. So I'm going to show you an example because I guess this is a really good, an interesting full solution where someone might have already been using crash reporting. So you might be familiar with this screen.
Oh yeah.
So this is a crash report. It's a Postgres SQL timeout. Yeah, lots of bits of code here. So we can see there's a stack trace. We can see where that occurred. We can even jump into GitHub to see the code that was responsible for this query.
I love that, right? That connecting the dots, that can't be underestimated enough, right, Jeremy? That going from an error right to that line of code in source control, for somebody who's doing quality assurance or somebody who's doing that first level triage, oh my gosh, right?
Yeah, I mean, it's been so valuable to me, especially if you're on, you don't actually have your solution open, you don't have access to the code. From the browser, you can actually, you might be on call, you've woken up in the night, there's lots of errors occurring. You can jump here and go and actually inspect the code. What's happening? Why is this error occurring?
Hopefully, if it's something stupid, there's an extra equals, there's something flipped the wrong way, because you can do that quick commit in, right? You can quick edit your code on GitHub. Maybe if you have CI/CD wired up, you can automatically save the change, let continuous deployment fire, and hopefully fix the build all from your phone.
Wouldn't that be ideal, eh?
Wouldn't that be great?
Yeah.
Okay, so we're familiar with this screen. We folks who have used crash reporting, they've seen this before.
Yeah, so what we've got now is an extra tab in here. So what's happened is when this exception was thrown on the server, we actually profiled the request. Now we can drill in. You can see that there's a trace here of the request. Let's just move that up a bit.
Yeah.
There's lots of setup here that's occurring. Now there's a request to load what we call transactions, and you can see from the size of this that this entire request is dominated by the SQL query.
Yeah, that looks ugly.
We can see the query that was executed. We can see that the server that it was executed on and which database it was executed against. And the time here is the time of the database query. So we can see that that's a 25-second query, which is as timed out.
Yeah, there you go, Nibro. You were asking about how long those queries run. There's one. Okay.
Yep. So the other thing we can see here is that there's this little red dot in the trace. So if we weren't coming at this from the crash reporting aspect, I can go to the other view. So if we go and view this trace from, say you were coming at it from APM rather than from crash reporting, you can see the little red dot is an indicator that an exception has occurred. There's been an error in this trace.
Actually, it's hiding just behind us. Tell you what, here, I'll hard our cameras real quick here so folks can see us.
I'll just bring it up.
Oh, okay. I guess you can scroll.
I can scroll and I can zoom in, and
there it is.
So there's a bit more information. Here it is. Went past it. It's a little dot. So there's that same NPG SQL exception, which again, from this perspective, we can jump to crash reporting to view more information about that. But what I really like about this is I've now got the full picture about what went wrong, not just the query, or I don't know that just that an exception occurred. I know exactly the query text. I've got parameters in this query, but I can actually get those parameters from the crash report, because the crash report has recorded the HTTP information that came from the client that was
So you've
submitted
got the
to the
whole
server.
request there that you can access and dig through. Nice.
And I'll show you another really cool thing. So rather than having to, like with crash reporting, when we had the stack trace, you could click on a line in the stack trace and go to GitHub, see the code. Well, we've gone one step further here with APM, in that we've actually pulled that code out of your repo. This is happening only when you view it, so we're not downloading, we're not caching that source code on our servers.
Okay.
We don't want to we don't want to manage your code, but we want to show you your code in the application.
Sure.
So now I can come in here and I can see, well, how were those parameters being populated? What were they being populated with? So I can see that parameter 0 was the application ID. So I can click on that. I can see, yep, P0 application ID. Yes, that makes sense. And I can go back to that crash report. Let's just bring that up in a new window so I don't have to keep jumping back and forward. And from the HTTP information, I can see, here's the application ID, 7314. So I can now start building this query and execute the exact query against that database server to try and reproduce the problem. Yeah. Because a lot of database queries aren't usually, well, sometimes they are just bad queries, but sometimes they're related to the actual size or volume of data. And the only way you can reproduce that is if you're actually, reproducing that query with the exact parameters.
Yeah.
Isn't that cool?
That's very cool. That is gonna, right? I can't tell you how many times in my production applications I accidentally knocked down, right, the production web server because I had a bad index. I was missing an index, right? I had a query with a bad parameter coming in. Chat room, come on now. Confession time. Step up to the plate here. How many of you have written a bug, made a mistake that took down production? Can I see an F in the chat room if you've accidentally knocked down production because you wrote a bad database query? Come on now. It's okay. We're all friends here. See, Zaflu has it dropped. Just drop an F in the chat room. It's okay. Nobody's going to accuse you or anything. Nobody can see it here, right? It's just us. See, we've all done this. It's okay, friends. And of course,
I think I should be putting an F in that channel as well. I'll own up to it. Hey, we've all done it.
I've left create database scripts that fire for Entity Framework. I've left them in the beginning, like the scaffolding stuff that I use in debugging QA environments. I've left them running. So when I got to production, the production machine restarted and it re-executed the create statements and crashed and wouldn't come back up. I'm like, what did I do? And I left the create script still set up in there for my dev and QA environments. Right?
Wow, we're seeing some real horror stories here. And Musical Bookworm even says that, hey, I'm the DBA and I've done it.
Oh my gosh. Right? We all do these things, but to have a tool that's going to be able to show you exactly where those things happened is invaluable. For tier 1 support for the operations folks, you're glad you have the tool when it's there. But when you don't have it and you need it, it's like, why didn't I install that?
Yeah, so that sort of thing, I guess. So I wind back because I was, I guess, starting to talk about a thing called issues. So issues are, where we have, as we're seeing your traces come through, we're analyzing those and we're looking for common problems, queries that are taking too long, N+1 type queries, which are quite common in an entity framework, where you're using an ORM, an object relational mapper. You're writing code and you're doing, you're writing link statements. It might be users.toList and, team dot users of that team, where the email address, I want all the email addresses of a user in a team. And what you've done there is you've loaded a team, you've then told ORM entity framework to go and load the users because you want the email addresses. And what you might not be realizing is that that's actually loading each user independently. So if your team is made up of 10 users, that's 10 database queries. If it's 1,000 users, that's 1,000 database queries.
But that type of structure makes sense when you're in like a desktop application, or maybe, right, you're working against SQLite in a mobile application, and you're just going from page to page, and you're saying, show me the details of this user. Okay, load the next one because I have all those IDs. Here's what the next one is. Go fetch ID 2 and present its information. That's okay, but when you're displaying a grid, oh my gosh, Jeremy, that's a pain in the neck.
Yeah, and databases are meant to be queried, bulk type queries. You should be saying, select all the users. It does really well at selecting large amounts of data back. But doing lots of small database queries they're usually really quick, but not a great way to treat your database. It's not going to be very happy about that.
So for some of the beginner developers that are watching out there, right, learn a little bit about set math, right, set arithmetic, so that when you do work with the database, you make as few queries as possible and get all the data that you need all in one request.
Yeah. So I'll jump into an example really soon about an N+1 that we found in our own production systems through using the APM tool.
Okay.
But I'll just finish off, I guess, a quick talk around issues, because this is quite interesting. When you come in, we're going to create some default rules for you. And these are things that we think are important that you might need to fix. So a lot of traditional APM tools, you'll plug them in, you'll get a stream of data, which you can go and sift through, which is great, and we do have that information there as well. There's a section that we call Discover, where you can go and discover all sorts of things. But
it's the literal fire hose. You're getting everything spewed at you, and you have to sort through it.
That's right. Yeah. And that's great. It allows you all the functionality to go and filter and look for things. So if you've got a suspicion that there's a problem in a certain part of your code base, you can go and discover that, and you can filter to a given request or a given namespace if you know that that's happening within a certain part of your code. But what we've done here is you plug in the tool. We want to give you something that you can action immediately on day one that you add RayGun. We want to try and make your life easier. We want you to have a great experience and actually fix some things so that you can go to your boss and say, I just removed 100,000 database calls, or go to your DBA and say, you're going to love me. You need to buy me a coffee or a
take me out for a fine adult beverage later.
Yes, something like that.
Yes.
Because I've just reduced database load by 50% because we had this really bad problem, and hey, RayGun just told me about it, so I didn't even have to do any work to find it.
Okay.
So that would be our ideal situation when you plug in APM. So we've got some default rules, chatty API, so that's where you've made a request, and this could be common in microservice architectures that people are moving to, where you're calling the same API endpoint many times, and there may be a bulk endpoint that you could call that's much more efficient. We talked about N+1 queries, so where you've done one database query, but then that has fanned out to do one more for every,
Right. This is that multiple. You've requested the list of users, but it has to go get each user as you paint them on the grid, and it's a secondary query that follows them. Yeah.
Overused API, slow API calls, and then slow methods, queries, and traces. And then we've also given you the ability to create your own rules based on sort of a combination of things.
Okay. So Nibro is asking in the chat room, how do we set up RayGun, or are we going to see that in another session? So Nibro, we did that just a little bit ago. You'll be able to find that on the video on demand, and we'll have this video, just like all my other videos, it'll be over on the YouTube channel a little bit later.
Yeah, and we can wind back a little bit, because I guess I showed you how to set up APM, which was a no-code exercise, and maybe once we've gone through some of the APM examples, we could go back and how to set up crash reporting and real user monitoring, which will actually see some code then.
Yeah. All right. So, welcome, Brave Cobra. Good to see you. All right. So
yeah,
now
what I've got here is something that we found in our production systems. So this is I find this really interesting because when you look at this, this is a web API call that we make. So you load up a crash report. On a crash report, it's got an ability to assign this crash report to someone so that they can, they're now responsible for fixing it.
they've got a triage, but you're already scaring me with this line right here, Jeremy. That line with all those yellow ticks. I'm looking at that and going, what happened there?
Yeah, so what each of these yellow ticks are database queries. So we color code the trace. We've got my code, we've got known libraries, and we've got database queries. So what we can see here is a query being repeated over and over and over. I think it's around 60 times to
Oh my gosh.
select a user. And,
Yeah, I can see just over your head there, it said there were 63 queries. Oh my gosh.
And I'm pretty sure this was just to get the user's name and email address. And so this is using an ORM, like entity framework, where it's that exact problem. It's coming from the perspective of, I want to load a list of users. Those users, I need to know the teams and the users that are in those teams. And so this is 60 in this case, or 63, but that's including a couple of other queries that are happening around it. The overall time is 230 milliseconds of the whole request, and the time to load all of these database calls is only 84 milliseconds. So this is not something that, if you were looking at logs around the time that something is taking, this is probably not something that's going to stand out to you. 84 milliseconds, that's nothing. No one's going to notice that because it's loading fast. These are fast queries.
Less than 1/10 of a second. That's great. Yep. More power to you. Well done. Good job.
Yeah, but could you imagine if that team was 100 users and then that's 100 database queries?
Yeah.
So this is not something that really raised a concern to us, but it was something that just by plugging in APM, it says, hey, you've got an N+1 issue. And it's happening thousands of times, hundreds of thousands of times. Because every time someone's viewing a crash report, it's loading this.
Wow.
And hundreds of thousands of times a week. I think it was around the 10 to 20,000 times a day.
Oh my goodness.
Yep. So, we saw that, we fixed it. It's now 2 database queries, and the total time was 2 milliseconds. So we went from 84 milliseconds to 2 milliseconds with one 2 millisecond query, where it's doing a much more efficient query. In fact, a union query of both the users and teams to get it all back in one go, and just the fields that we need. So we're actually optimizing bandwidth between our database as well. We're not selecting back entire user records.
Very cool.
Yeah, so 2 milliseconds.
I love that you were able to detect the issue, even though it wasn't on your radar because of performance reasons, but detect that, hey, this is going to be a problem, and go and fix it. Very cool. Hey, Small Bacon, thanks so much for the resub there. I appreciate that. 6 months in a row. That's going to put you into a blue hat badge. Thanks so much for your support. And Jeremy, for every cheer, every subscriber that we have here on the channel, I make a donation this quarter to Coder Dojo. So those are folks that are they're training folks to train trainers and build facilities all over the world so folks can learn how to advance their technical careers. And thanks so much, Small Bacon, for the support. Now, okay, it detected an N+1. That feels like something that, because you're already looking at database queries, you can see that the same query and the same request fires a dozen times, 60 times, right? Gosh, what is this one we're looking at now?
Yeah, so this is, again, another example of something that we found in our production systems. Now, this is more of a, how do we optimize this to make this load faster? So this was picked up as a API +1, where we're calling the same API point over and over, multiple times in a single request. And all of this is happening synchronously. We'll make one request, we make the next request, then the next, and then the next. And each of these just adds up to, again, I mean, this one is significant. It's over 1.5 seconds,
Yeah.
1.6 seconds. So it's raised an issue, and there are, with modern coding techniques, we can optimize this. We can do things in parallel through very little change to your code. You can use something like a task to execute multiple things in parallel. So
right,
this is
that
going to require
asynchronous processing that in C#, in VB.NET allows us to do these things asynchronously, run a bunch of them at once. Brave Cobra says, this graph looks like Jaeger for distributed tracing or Zipkin. I'm not familiar with those tools. Are you, Jeremy?
No, I'm not either. I guess what this is showing you is it's a web request. In fact, I think it's a web API call.
Okay.
That is then requesting. So each of these green blocks is a request out to another microservice or another external service that we host within our infrastructure.
Okay.
And this one specifically is around going and getting Elasticsearch information. So this is when you view a crash report, you've got paging. You want to see what the next one is or the previous one is. So it's trying to determine what the next and previous crash report instance is, given the crash report that you're looking at.
Okay.
So that's what the surrounding neighbors and next neighbor. So what we've got here is something that really requires more understanding of your code. We can raise this issue to you, but we're not going to really be able to tell you how to resolve this because we don't know what your code is doing. There may actually be a dependency in each of these calls that one actually feeds something into the next one, or that feeds into the next one, which then means you can't really do this in parallel. You may be able to do it in a non-blocking way so that the thread isn't blocked. But in this case, we were actually able to break this up into parallel requests. So what we can see here is the same request, but some of the information's disappeared. So what we actually see here, you might have noticed it up top, is there's two little bars.
Yeah, they're stacked.
We had this, there's a little flag indicator in here saying, actually a task was started at this point. And that task executed on another thread.
Okay.
So with APM, it's able to detect multiple threads being executed in your application, and it pulls all of that information in together into a single trace. So you still get the full picture of all of the things that are operating within your request. So now we can see that these requests are being executed in parallel and rather than sequentially, and we can get a performance gain through that type of code change.
Sure.
So
And
you can go down into the code. You can see here I've just got a couple of task run statements. So previously these were just this would execute and then this would execute. So the change really was, well, let's just wrap these two blocks in tasks and then we'll block.
Wait for them done.
Yeah, we'll still block because we need the result of both of those tasks, but we can let those tasks run in parallel
at the same time.
And we can, and we can save, in this case, 860 milliseconds off the total request.
Nice. And I love how, right, when we think about parallel processing, asynchronous processing of tasks, right, sometimes that's kind of hard for developers to get their minds around. But this lets us really visualize it. It ran this task and it ran this task at the same time, and you can see that because of the visualization here in the graph, right? So we know that those two are running at the same time.
That's right, and this actually tells you that you are doing something correctly. That by running two tasks, you are actually running these in parallel, and you are saving time in the overall request, because there are other examples, and I think I had one. I might have to, sorry, I'll just switch over to try and find a link. There's one where I guess it gives you an understanding of code that's executing in parallel, but is not actually worth doing in parallel. So you know, with code that is highly parallel, you can see in this example. So here's another example of I'm doing a task in parallel.
Okay.
So I've fired off another thread to do some database execution in parallel. But what you're actually seeing here is everything is blocking. Nothing else is actually executing. There was a small database request, so we were able to optimize 1 millisecond off this total time.
Yeah.
But we've spawned off another thread to do this other request in parallel, because parallel programming is great. It allows us to optimize it. But what we've actually introduced here is probably more of a performance smell, in that you've tried to do something in parallel, but ultimately everything is blocking, and the overhead of probably marshalling the context back and forward between threads is not worth the 1 millisecond you've saved in doing that other request in parallel.
Now,
you may as well have just left the code.
Oh my gosh, yes. Now, Brave Cobra is asking, can you see the parameter values? And we did see those, because you can go back up the request stack and you can see the entire request that's being processed. So while we can't see the exact parameter values that are being passed into the database query, we can see where the values are coming from that are in the HTTP request. Another question that we have here is, when you have these, right, so clearly when there's 2 threads being operated on, no big deal, but how does that scale if there's lots of threads, right? 10, 20, hundreds, right? And gosh, well, Lord help you if there's hundreds of threads running in one request. But when that does scale, does the user interface here handle that nicely, right? I see a collapsed thread link here where my finger's pointing, but it feels like there's going to be a little bit more to monitor and sift through there when you get right. This is one that's been excessively parallelized, asynchronized. Yeah. Yes, there's a word there. I don't know what it is, but right, it handles it well, doesn't it?
It does, and we will detect all the threads that you have running in a request and separate them out. Where we can, we'll show you a different view where we actually collapse all of this up. If you are executing multiple stages on different threads, and it is actually happening in more of a sequential nature, then we'll collapse those up to show you a flattened view of the sequence of things, more than the fact that things were operating in parallel. Okay. The interesting thing is, when you start drilling into how the .NET framework works, say if you're using the task parallel library, the TPL library, where you can do parallel for each, parallel for loops. And that parallelizes the execution of a loop. But what you might not realize is that the .NET framework is actually managing underneath a thread pool. So it will determine which thread something is run on, or if there is even an available thread to execute your code. So you may, in this example that I showed of the API calls, is the perfect example of, I've started 2 tasks. One of these tasks is actually executing on the thread that I started it on. It hasn't spawned a new thread. So the library, the .NET framework is actually able to understand that the first task, it fired off into a new thread. The second task, it decided to execute on the same thread, because nothing else is needing to execute on this thread until both of these complete. So it's going to reuse threads. So even if you are submitting lots of things to a thread pool, the .NET framework will be managing that, and it will be reusing threads where it can, and optimizing for those scenarios.
It's interesting when you start digging into how the framework works, doesn't it? Brave Cobra points out the max degree of parallelism. That's a parameter,
That's right?
That
is, yeah.
In the parallel for, isn't it?
Yeah, in parallel for and for each, you can set that max degree of parallelism.
There you go. Yeah.
Which even then, it's more of a hint to the framework. So it will try to maximize up to that number, but it may be that it doesn't have enough threads to actually, if you set that to a really high number, it still may not have enough threads
1 million threads. Sorry, you've only got a single Pentium processor, friend. Can't do it, right?
Yeah.
So now question that has come up in the chat room, and I wanted to hold off till we were done looking at this sample is, now, how does this compare, right? There's clearly advantages to using RayGun versus one of those stock services that come on the cloud platforms, whether it's AWS with X-Ray or App Insights on Azure. RayGun has some advantages over those products, doesn't it?
Yeah, I would say so. And we strongly believe that RayGun works well with other monitoring and performance tools. I'll take the example of Application Insights. Microsoft have done a great job there of providing a tool, and largely for free, that gives you access to a huge amount of information. But this, I guess, was the problem that we found, is you plug in that tool and you're presented with so much information, you kind of get overwhelmed. You're not really sure where the problems are or how to drill into it. And some of it, while they've done their best, it is not logical. And I was at a user group last night where I was talking to a developer that asked me this exact question. He uses Application Insights, and I was talking about this live stream and about RayGun in general. And what I would like to say is that I think through the concept of issues, we drive you to things that you can action, and we try to highlight the actual problem areas of your application, rather than relying on you to have to go and drill into the information and find the things that are wrong. We're going to present those to you and give you something that you can action on day one.
That built-in intelligence is so valuable that RayGun provides you to find those actionable items like we're seeing here.
We also think that we go a bit deeper in terms of the information that we provide. So rather than going really wide in the amount of information that's available, we go quite deep on specific information that's more valuable to you. So we'll give you a lot more information about a trace than Application Insights would.
Cool.
And we give you ways also to tailor these traces to focus on things that are important to you. Because of the depth and the detail that's provided in these traces, sometimes they can be quite overwhelming, where you might be using a third-party library, or you might have a utility library that does a lot of thousands of small requests to reformat something or calculate a number. Sure. So you've got these utility libraries that really don't require monitoring, or sort of you know that they're performant. There's no chance that they're going to be unperformant, and that they might just make your trace a lot quite busy with a lot more detail.
Gosh, an API that uses JSON.NET, right? Everybody uses JSON.NET. Don't tell me JSON.NET is running quick or running slow. It does its thing. I'm not touching JSON.NET. Let JSON do its thing, right?
Yeah, so what we've provided is a way for you to go and blacklist that sort of information. So you can come into the blacklist and you can blacklist things, whether it be at a namespace. There's a whole section of the code that you're not interested in, a specific class or a specific method. So you can blacklist to any level, and that will just remove that information from the trace so that it's not, it just tidies it up and makes it nicer.
Absolutely. So, folks in the chat room, let's reflect over there for a couple questions. Janescu asks, well, what about system text JSON? Right. So, new versions of ASP.NET Core, we're starting to use system text JSON, so we get a more optimized JSON experience. You can filter that out too, right? It's that namespace.
Yeah, a lot of the system stuff we've already blacklisted. So Microsoft and system are generally things that you don't have control over. So seeing those in your traces is not helpful.
Sure.
You're more interested on being able to optimize your code and things that are within your control. We've already gone, I guess, through the process of blacklisting a lot of that stuff.
All right, give you that intelligence that gets you right to your code and how your code is interacting, your application. And there's a question here about, is this based on the Open Tracing API? I'm not familiar with that API.
No, it's not based on open tracing. This specific, so the .NET profiler is using the CLR or the core CLR profiler capability. So it's built into the framework. You can write a profiler. You need to do that in C. It's not C#, so C and C++. And you create a profiler, and basically that allows you to hook into the running of the framework and then receive information about how the code is executing.
Now, somewhere our friend Fierce Kittens, she likes to hang out in this chat room, and Jeremy, she taunts me about how she's a better C++ programmer than I'm a C# programmer. Okay, she's going to be laughing that yes, of course we're writing fast performance profiling stuff with C++ and not C#.
Yep, not C#.
I don't see her out there. I know she's going to taunt me on this later. Somebody clip that. I know it's coming. All right.
But no, it's interesting that we raised the open tracing API because that is, I have seen that coming up a lot more, and something that we should look to try and support. Now, because that also opens up a lot of other language options as well.
Now, what does, for folks who don't know, and folks like myself, what does the open tracing API give us? What kind of feature set would that enable if we were using that with our application?
It's basically an API to, I guess, standardize the collection of tracing information across languages.
Okay.
So independent of the language, you can build up a trace of what that request, so whether that's executed in Ruby or whether it's in .NET. It's, what was the time that request took. And it is a lot more high level, so you can't go into the detail that we can see with a native profiler.
Okay.
But it provides a great sort of high level information, and it's nice that it's language agnostic.
Okay, that makes sense. A good way to get across all the different frameworks and ecosystems.
That's right. So you'll have similar to this, you'll have a collector or some sort of agent that's able to understand open tracing information, and then a language specific collector, which there are a lot of them already written, that you can just plug into your application and start collecting that information.
But they're broad strokes with that. Like you said, you're not going to be able to get the depth that you can when you have the native profiler attached like RayGun. Cool. Yeah. All right. Now there was... Go ahead.
No, I was just thinking what else to show.
So we've seen how we can detect a couple things here. We've seen the N+1 problem, how it detects that, and we've seen some of these things. What about if I've got a slow running API, right? If I hit some sort of endpoint, I'm making a query out to, for example, you were showing how the APM interacts with Crash Analysis interacts with GitHub to show you some of the source code that might be responsible. What happens if I was making an API call out to GitHub and I noticed that's running slow? I thought I saw you had a rule for that as well, to detect slow running external APIs.
Yeah, so that's, I guess, what this is.
Okay.
So we do have rules. So the green bar is effectively an external API, something that is a web request, for example. That could be GitHub, could be your internal APIs. So internal and external are kind of bucketed the same way.
It could be requesting Twitch APIs, right?
That's right. And we had rules around that as well. So you've got slow external APIs, so I can go in and I can define what is slow in the realm of my application. So these are quite useful if you've got SLAs that you might need to stick to. You could initially ramp these up a bit if you want to be a bit more generous, and then sort of set goals for yourself to bring those down over time, and then just slow incremental improvements to your application.
Sure. Set it to a high number to start. As you fix the performance, wrench those rules down so that they become tighter and tighter, closer and faster to ensure that you fix things. Nice.
And then you can create custom rules to say, maybe there is a specific API within your application that you're interested in. So you could say, well, if the request is to my checkout page, then I really want to know if the API call or the database query, probably more likely, is more than 10 milliseconds. I really want my checkout to be performing well. So you can customize and tailor rules to really sort of focus on the areas that you're interested in.
Was that credit card processing request, did it take longer than 5 seconds? Oh my gosh, we want to make sure that we're collecting money quickly.
Yep.
Yeah.
Right.
All right. So, I mean, that we've got some cool things with samples. What's this thing here? Blacklist. I see blacklist in the APM features there. What's that one?
Yeah, we talked about blacklist. That was where you're wanting to clean up your trace
Gotcha.
and remove information. I think the other one that might be interesting here is sampling. So with RayGun APM, we've taken a different approach to how you pay for the product. Most other providers will charge you per server that you want to install this on, which becomes a bit of a problem where most applications are running in web farms. You've got maybe 3 or 4 servers that you're actually running your application on, and that's all load balanced so that the requests are randomly going to different servers. So if you've only got the budget to put that agent on one machine, then you're missing out on the 3/4 of the actual requests or the information that's happening on the other servers.
Sure.
So we don't charge that way. You can put RayGun on as many servers as you want. We charge based on the amount of data, I guess, that you want to send us. So what we do here is provide a way to control that information. So sampling, you'd say, by default, I only want to capture 1 trace every minute of this URL. So each URL that is requested will capture 1 in every minute. And you can change those to be minutes, hours, 1 or 2 every 5.
My gosh, I can imagine you're going to want to throttle that. You're going to want to sample infrequently on days like, if you're that storefront, on days like that Black Friday, that Friday before the holiday season shopping starts, right? Don't capture everything.
Yeah, but what you may want to do is also be, there is again a specific URL that is a problem or that you want to monitor more closely. So you can override the default and say that, no, I really want to know everything about my checkout. So I can say, let's add an override where I want to capture 1 of 1. I want every trace of someone hitting my checkout, or 1 of 2.
Okay.
Or again, grab 1 every 10 seconds if it's Black Friday and that checkout's really getting
get hammered. Sure. Yeah. So we're collecting all these samples. We're collecting all this really rich trace data. Bravecubber has a couple of really good questions about that data. How do we prevent passwords from leaking into the trace? Some of that secret information that we don't want to expose. Does RayGun have a way to handle that?
It does. So it's not actually capturing any password information. So that's what we saw earlier, was that combination of crash reporting and APM tracing. So the trace is actually just tracing your code, and it's the entry and exits of code. So when we see this information, this has been pulled from GitHub. This is the code. So it's not the parameters. The information that you see on here is really just how long those calls took to execute. Database queries, again, the only information we're pulling out here is the server and the website that it executed on. We're not actually capturing any of the data that was returned from that query. So there is no user information or sensitive information in a trace.
Okay.
With crash reporting, so this is definitely where you're more likely to run into the scenario where you're going to capture someone's password or credit card or something like that, because we're capturing the HTTP information.
Sure.
But RayGun crash reporting has tools built into it to filter out that sensitive information. So you can, by default, say, I want to remove any sensitive information where the key is password or credit card or any of those quite common things. So we provide tools to filter the information before it leaves your application. So
nice.
We also provide tools to, if accidentally you have allowed some information to make its way through, you can actually go and delete these crash reports, so get rid of that information.
Okay.
But you can also filter at our entry point. So again, you could say if the trace contained specific information, then let's filter that out and block it at our entry point. So yeah, this becomes quite a useful tool if you've actually got something in production. You can't make the change immediately, but you need a way to stop that information flowing through. And you would come in here, you'd set up a rule to filter that out.
Now, the follow-up question is, of course, privacy information, GDPR, right? That was a big buzzword in our industry for the last 2 years, and it's still, right, folks are concerned about privacy of their data. If there's a GDPR request that comes in, do we have a way now to clear out that data from the trace reports, or is that something that kind of falls under the maintenance of the application? We need to keep our trace reports.
It's not going to affect your traces so much. It's more going to affect the user information. So GDPR is around personal information, identifying a user and allowing them to be treated anonymously. So RayGun is GDPR compliant. We were GDPR compliant from day one. So we have all of the tools in place to allow you as a RayGun user to come in and remove user information. And also state your GDPR compliance. But ultimately we provide the way to get rid of or anonymize that information. And you're really not interested in collecting any personal-viable information, then we provide tools to filter that out before it makes its way to us.
Nice. Great. Thanks for the questions, Brave Cobra. Appreciate that. And anybody in the chat room, if you have questions about how to manage your applications, how to monitor your applications, how to do performance management and monitoring, let us know in the chat room. We've got Jeremy here, and we want to show you all the great stuff that RayGun has for us in their new APM application right here in the
Do you want
stream.
to jump into an example of setting up crash reporting and real user monitoring?
Yeah, let's do that. Maybe we can have some of the folks in the chat room try out and help us test some of these websites.
Yeah, so we got APM running. Just to recap, that was just installing the installer and configuring the agent and profiler. Didn't require any code changes. So now if we want to do crash reporting, we've got a ASP.NET Core. Gosh, that's a mouthful.
I'd like to buy a noun, please. Can we just put something else? Yep. ASP.NET Core ++ R2.
Yeah.
Gosh.
Yeah. So we've got that. We can do crash reporting at the server side, and we can do crash reporting in the JavaScript as well. So we've got two options there. So let's go through the process. So what we're having to do is, I've got my eShop web application here just running in Visual Studio Code. I need to add a package. So I'm just going to do that via our command line. So I need to add the Mindscape RayGun for Net ASP.NET Core package. So Mindscape, for anyone watching, is what the company used to be before it was RayGun. So Mindscape were a developer tools company, developed things like Lightspeed, and which is an ORM that I was referring to earlier, and some WPF tools and sort of a whole raft of sort of developer tools. And RayGun actually came out of the need to monitor how people were using these tools and what problems were occurring. And because these tools were being installed on customers' desktops. So
Yes.
when you enter that space, you have little visibility as to what's actually occurring, and you're relying on people to communicate with you about what's happening. And then, as developers, you're trying to find out what's going wrong by asking questions. It can be a bit hit and miss.
Oh, for sure. Oh my gosh. Right. I think about, we have a bunch of friends in the Twitch community that run various chat bots to help manage and interact with chat as we're talking here. And when you have to debug some of those folks' chat bots that, like you're saying, running on somebody's desktop on the other side of the country, on the other side of the world, how do you do that? To be able to collect that data is invaluable.
That's right. And automatically, not relying on someone to actually tell you that there's a problem. Because that was the most interesting thing in developing RayGun, was that we knew that there were problems, but we had no idea actually the scale of problems, because I think the rough metric is around 90% of people won't tell you that something's going wrong.
Yes.
Yeah.
Right.
So,
this is, and that you would think, without, especially with social media, folks would run out there, hey, Jeff, there's a problem with this. This doesn't work. You need to fix this, right? But with software, a lot of folks, unless they get really irritated, will just sit on it like, okay, it doesn't do that. What it's supposed to.
They'll just restart the application. I think it's ingrained into us. Just have you turn it off and turn it on again. So people will do that, and usually that resolves the problem. And then they won't report it. So there's a lot of just unreported errors or crashes that are happening in your application that you really don't know about. And unless you're using a tool like RayGun to automatically capture that information and report it to you, good luck.
It's going to be hit or miss, right?
It is,
but when you have it installed, you're going to get it on a regular basis. You're going to get it as it happens. So,
that's right.
All right, so you're going to add... You got a couple using statements here?
So what I've done, so with ASP.NET Core, they've got the concept of a startup pipeline where you register your modules into the pipeline and things execute. So I added 2 statements in here. One was to basically add RayGun as a service with some configuration, and that configuration is just allowing it to pull this API key out of the configuration file. And there's a whole lot of other configuration options that you can go into. And then the other one was I need to now configure to say I want to use RayGun in my processing pipeline so that it will automatically capture unhandled exceptions. So if there was any error in your application, then having this in here will automatically capture those exceptions before they result in an error page, a 500 error page to the user.
Cool. All right. And there was a question here in the chat room that says, noticing from Brave Cobra, notice that ASP.NET Core 1 or 2 running on Windows, there's a run on Windows requirement, and Commander Keen is saying that you'd need .NET Core 3, as some of the profiling APIs haven't been added to Linux until .NET Core 3, which is coming out here in September. Is that right? This will work primarily on Windows, great for .NET Core. But with the next version, you'll be able to get it on Linux as well.
That's right, yeah. So, we're trying our best to get the profiler working on the .NET Core 2 profiler, but on Linux.
Okay.
But there were, I guess, issues in the core CLR, so that's really something that's outside of our control, which we submitted to the GitHub repository. So all of that's open source now, which is great. Kudos to Microsoft for making it all open source. So we were able to get in there, log issues, help them diagnose it, do all the testing for them, and just help improve that code base. So
awesome.
It's coming in .NET Core 3.
I want to thank Robert Tables, has just rated our stream. He brought 16 viewers over from his channel. Thanks so much for joining us, and thank you, Robert, for sending over your viewers. Welcome, Raiders. I appreciate you joining us today. I'm joined by Jeremy Norman here from RayGun, and we're learning all about how you can do crash analysis, how you can do automated program monitoring using RayGun. And we're taking a look at how easy it is to set this up with our .NET applications. Thanks so much for the raid, Robert. And why don't you let us know in the chat room what you were working on there while we continue to look at how easy it is to add this to our ASP.NET Core application.
Yeah, so that was all that was needed to get crash reporting working in the back end for the ASP.NET Core, but I'm also interested in capturing JavaScript errors. So I'm going to also add in some JavaScript, a little JavaScript snippet to load in RayGun for JS. And then I also need to just, again, configure it with my API key and tell the library that I want to start capturing errors that occur in my JavaScript.
And this is, it looks like you're not adding any more than I would if I was adding in Google Analytics.
That's right.
Something to track and do that analysis.
Statements. I can optionally, if I have an authenticated application and I want to capture information about who the users are, I can also add in another code snippet to sort of tell RayGun who the current user is.
Ah, okay.
Which is quite useful. I'll just pop that in there because I'll show you how it works with ASP.NET Core and the identity that's sort of built into it.
Okay.
So in this solution, it's actually got a login partial that is, I guess, displaying information if the user is authenticated. So I'm just going to borrow that little snippet there to say if the user is authenticated, then I want to track who the user is in RayGun as well. So now this code block is only going to execute if I have an authenticated user. And I'm going to...
Now, let me ask you there, on line 77, it looks like your RayGun API key is going to be shared in JavaScript with folks that are using the application. You're kind of stuck with that, right?
You kind of are. There isn't really a way to get around that.
Okay. But we can constrain that with some header filters.
Well, I guess it's in the JavaScript, so it is completely visible to anyone that can view the source of your JavaScript. You can minify it into external files, but ultimately it is visible. Someone could submit or reuse your API key, and we provide ways to allow you to rotate that API key if you find that someone is maliciously using it for the wrong purpose.
Okay.
To be honest, it's interesting because a lot of developers do ask us this because they see that and they go, "Oh, but it's in the clear." But I think in my everyone on the Twitch is going to prove me wrong now. Because they're going to grab that API key and going to start submitting some errors. But no,
I'm going to cover it. I'm going to put my hands up. I can't reach it.
In the over 3 years that I've been at RayGun, I've never seen an instance of a customer, at least, reporting that data is coming into their application that is not their data. In the case where someone was submitting information to the wrong API key.
Robert Tables in the chat room chimes in and says, RayGun is something I really wanted to use at my previous company. It's seriously cool stuff. Thank you for the kind words, Robert. We really appreciate that. And it is, right? We're seeing easy to set up. You've now got automated logging of who the user is. I love how you've mixed a little bit of the ASP.NET information about the user into the JavaScript there so that we know who the user is that's acting. Really great stuff.
Yeah, so the final piece was that I also wanted to enable the real user monitoring tool. So real user monitoring is monitoring the performance of your user that they are experiencing on the client. So whether that be the browser or a mobile application, it's going to measure what is their experience from their browser, their internet connection, their location in the world, which is quite an interesting thing to collect and analyze. A lot of people might be more familiar with synthetic analysis, where you can configure a tool to go and make requests to your application from given locations around the world. Now, the reason they're called synthetic is because they're not real users, and they are limited, I guess, to specific locations and specific scenarios. With real user monitoring, you're literally capturing the information of every user that's using your application. Okay. So I'll save that. That's all configured. And that was just, if you've already got crash reporting in, it's literally adding one more line to say I want to also enable Pulse is what it's called in this case.
Nice.
I'm just going to shut my application down because I'm going to need to rebuild it.
Yeah. While you're rebuilding, Commander Keen chimed in the chat room and says it's worth noting that the API used there is for submitting only, not reading the data. So it's similar to worrying that your Google token might create fake data. Yeah, right. It's creating fake data on somebody else's account. They're not able to see everything that happened to your application. All right. So, Robert, are you using RayGun at your current employer? Is it something that you're talking to them and they're interested in looking at? Let us know. I might know somebody who can help you with that. I'm just saying.
Okay, so I've republished my application, and I'm just going to start it up again.
Cool.
Yep. So now what we'll see, so I'll go back into so real user monitoring. Again, it's showing me the setup instructions. We've got a little spinner that's waiting for user information. So now I'll go and start browsing the application. What I'll just do is check that I configured it correctly. I want to see requests being sent to the events API. Yep, so I can see that we've got information being sent that's been accepted, which is great. Our API key is valid. So I will just do a few more actions. I think every time I add one more of these to the basket, I'm buying more and more t-shirts.
Everybody in the chat room is getting a t-shirt from the fake store.
Yeah.
There we go. We can see it loading there in the developer tools just above your head there.
Now I should just check that I'm not sending that into the other, because I was testing this yesterday, and of course I was using a different API key. Let's just check that I've got the right one.
No, Janescu, those aren't live coder shirts that folks are getting there. No. This is the sample eShop on web that was written by the .NET Foundation team, and shows off a couple of .NET Foundation projects, their logos, and some of the swag that you might want for some of those projects, right? It's a nice sample that shows how to get around a little bit of .NET Core. So. Queue up some more data there. Hey, Rambling Geek, good to see you. Welcome. So the .NET mug.
Right.
It's kind of nice.
Yeah, we've managed to get some data through, and now we can see myself. So,
but that looks like me. That's me in Philadelphia.
Like I'm located somewhere over here on the east coast of Australia.
Okay.
I'm coming to you from the Gold Coast. RayGun itself is actually located down here at the bottom of the North Island in New Zealand.
Okay.
That's where the main office is. But this machine and a web browser is running from an AWS instance in the US.
Yeah.
So because I'm remoted into a virtual machine and the browser and session is coming from that location, and that's where it's being displayed as.
So, chat room, see that? You learned stuff. You learned a little geography here today, chat room, okay? We're all over the world here today. We're in Virginia, we're in Pennsylvania, we're in New Zealand, we're in Australia. We're all over the place there.
Yeah, so you can see it started capturing information about me, the location I'm coming from, the browser, the environment that I'm using, along with the actual timing that I'm experiencing as I navigate around this application. So if I go...
And there's something to be said about the time you experience, right? That's different from how much the machine is involved in trying to present this, right? It's there's the experience is the important thing, right? And we can fake that out with caching and other stuff, but the experience is what's important.
That's right, and you can see that that first page load, that was when the application was starting up. You know, it was slow to respond.
Sure.
The load time was close to 2 seconds. So we're saying, you know, the experience is a little bit iffy. If someone was having that experience all the time, they're not going to stay on your website for that long. Once that had actually loaded and I started looking at some more pages since the application is now running, the load time was a lot better. 93 milliseconds is a pretty excellent load time, but that's all a local application. So I've got no latency here really between the application running locally and my browser running locally. So this is going to be a pretty good experience. But yeah, it sort of gives you that information so that geographically you can slice the data by browser or platform where they are in the world, and then you can drill on specific pages to see the load time in general, along with specific user requests.
Yeah, all the stuff being all that static content. Mm-hmm.
Yeah, how many JavaScript and images are slowing down the load time of your page? Could you optimize those?
Right. Start thinking about sprites, that kind of thing.
Yep. So minifying your JavaScript. Are they large JavaScript files? Things like that.
Oh yeah. And Brave Cobra is taunting us here, saying no requests coming from Antarctica. Come on, Linux is a penguin, right? I see what you're doing there. I see what you're doing over there, chat room. I tell you.
So if anyone wants to go to app.raygun.com, we can do a little experiment.
All right. So let me key that URL into the chat room. app.raygun.com. Raygun.com. All right. So I'm going to go there on one of my browsers here on my desktop. And I'm at the sign-in page.
Now, it will probably come up as an anonymous user, but if I'm viewing RayGun now, should see.
Right, and what happens if I try and sign in with GitHub? Is it going to try and find me? Sure, you can act... Sure. Authorize. Password. And it's going to want me to do two-factor auth, isn't it? No. Oh, I need to log into my RayGun. I don't have a RayGun account right now. That's a problem.
Yeah, that's all right. I guess it would have been...
But you can, I think you can see me bouncing off. That green there is probably somewhere near me. Right as I refresh and hit this a couple times. Now, does it only give you the information at that high level? Or it doesn't get in so close that it's going to tell you like what city I'm in, right? Or what street I'm on. Woo!
On this view, no, it really is high level, rarely down to rough geographic, rough coordinates. So it's based off your IP address, so it's only going to be as good as those IP lookup databases that we use.
Okay. So it's... I get it. So are you hitting it, chat room? Or are you trying to go to the appraygun.com website so we can see some more folks pop up on that? I'm going to try that.
Or we can even do the public website so people aren't having to sign in.
Just go to www.raygun.com.
Yeah, that's RayGun.com. And this is a lot more anonymized information.
There we go. There's the link in the chat room. So I'm going to go there with my phone that's on my wireless. I'll take it off Wi-Fi and I'll put it on my wireless, my Wi-Fi provider here. Helps if I spell the URL right. This is what I get for keying things in with a small phone. Incoming Belgian call. There you go. There's Brave Cobra in Belgium there.
I did notice this location popped up in the app as well from the previous screen. So maybe someone is following us around.
Yeah, there we go.
The UK and US, yep.
So you're getting that instant feedback of here's where folks are accessing, and right, if maybe you have a website and you're doing promotions and in various locations, various geographies, to be able to see those light up here is actually
I mean, this is interesting information, but I mean, a lot of people get a lot more, I guess, out of the performance of your actual pages and how you can optimize those. So interesting, really good tool there for monitoring the experience of your users. Combined with crash reporting, you can then also get and APM sort of a full picture of, well, what was the experience of the user at the front end? If they had a crash, what crash did they encounter and where in their session did they encounter that? And then with the crash and APM, you can then go into that more detail about, well, what was happening on the server, what was the code doing when their application crashed.
Very cool. Uh-oh. That Comet SVG is firing up 10,000 requests here, says Brave Cobra. What? 10,000 requests. I don't know what you're talking about. No. We're doing just fine. Oh my gosh. So this is great. We've got a complete picture of the application. We can see the users. We can isolate and be able to see performance by geography, and of course that's marketing candied for the marketing teams and folks to be able to see. Here's where folks are logging in from. That really gets those folks excited and interested, right? That they can see. Here's everybody connecting to the application. Oh, okay.
So what I'll show you is another way, I guess, to then bring all of the information from all of the products together. So every plan that you create will have the ability to set up a dashboard. So dashboards are our way of creating a view of RayGun data that may be specific to the developers or maybe specific to your managers. The managers or the executives might be more interested in seeing some of that information about where are people using our application, what is the overall experience of the application. And then as a developer, you might be more interested in, well, what crashes are occurring, what is the error rate of my application, how is my application performing in terms of load times on the server. So we've got this ability to build out custom dashboards. You can drag and rearrange these however you like. You can let's make that a bit nicer. Add in.
Yeah, somebody's OCD is going to flip because it's off by a notch there.
Because I put that over there and it couldn't automatically rearrange. So that's pretty bad. So you can build this up from user information, that satisfaction information, sessions, live session data. You've also got lists of information about, well, what are the slowest methods or slowest queries that are being executed in your application. Information about error groups, auditing information if someone's interested in seeing a stream of what's happening in a management perspective of RayGun. who set that error group to ignored.
Oh yeah.
Those sort of things.
So,
and then charts.
Oh yeah,
charts and charts.
And this feeds right into Robert Table's question. This is a lot of great data for those who know how to do something, then to transform that raw data into intelligence. That's what you're doing here. You're taking that raw data, turning it into intelligence that's important for your team or your organization, right? The tooling helps facilitate that, right? This is something that I think is very important because every organization is different, right? Your intelligence around your application is going to be different than mine, right? Or the marketing team's intelligence they want to know out of it is different than the operations folks. Is that something where you'll see folks using the tools so that they have different slices, right? They've got a dashboard that marketing uses, a dashboard that operations uses. And do you see some interesting combinations there?
Yeah, definitely. And especially in our own use of RayGun, we have multiple TVs set up around the office where there'll be a dashboard of the front end errors there, or the front end performance for the people that are working largely on the front end of the application. Marketing will have a different dashboard. They're more interested in what is the overall experience. And then here's another sort of interesting take where you may be a developer of a mobile application, and you develop iOS and Android versions of that, and you want to know, well, what's the uptake of the different versions? How are they performing? So this is quite a nice example of, and again, probably more at the management level, that they're interested in, is our iOS application providing a good experience versus Android, or is there a specific other things that we need to do to Android to make it better.
Now, I like the user satisfaction metrics there. How are you collecting user satisfaction metrics from those applications?
It's based on the time it takes for things to load. So there's an industry standard around, people that have load times lower than 400 milliseconds are getting a great experience. Everything's snappy, everything's loading fast. I think it's where you start going over 4 seconds that people are having a poor experience and are going to stop using your website. If every page is taking a long time to load, then there's a much higher chance that they'll leave. They'll stop using your application.
For sure.
So that's how that information is calculated based on load time experience.
So the follow-up question from the chat room is there any artificial intelligence to help detect anomalies in the experience, so that we can quickly identify, right? Oh, here's an outlier that we can go and address, or drill into a crash report.
We don't have any AI specifically. It is something that we're experimenting with at the moment, and there are definitely plenty of opportunities. We're doing a few different projects. One with university students, actually, which is a great way just to get people involved at a university level by providing real live data for them to do their projects with. Provides a much better experience for the students themselves. It's something that we promote a lot is one, doing internships, paid internships with university students to give them much better exposure to real life developer experience. So working in a real company with high scale, huge data volumes, and also providing data, anonymized data to university projects. But then we're also experimenting, so we'll be experimenting a bit more with AI specifically coming soon.
Yeah. Oh, that's awesome. All right. So, and it's just as easy to add the crash analysis reporting into a WPF app, into a mobile app, just as you did in the ASP.NET Core app, right? This is something that we can light up pretty easy.
That's right. So I can run through that. All the instructions are available in our doc site, but so raygun.com/documentation or /docs.
Okay.
But within the
there you go.
application, we also provide a way to set up the RayGun crash reporting or real user monitoring if it's available across a wide range of languages and frameworks.
Nice. Even Unity 3D there. Look at that. So you can capture crashes in your games. That's great stuff.
Yep.
Oh,
and the APM tool is, at the moment, it's just .NET and .NET Core.
Sure.
But we are developing Node and Ruby support at the moment. So that will be coming soon.
Oh, very cool. All right. Do we have any more questions there in the chat room? Anything else we want to know about RayGun here? Because we're nearing the end of our time together here with Jeremy. I want to make sure that any questions that we had there from folks were addressed before we headed out. This was great. I learned a lot here. I've got a number of applications we've been working on here on stream, and I definitely want to look at integrating RayGun so that as we deploy them, particularly there's one application where we're trying to build for a nonprofit. We want to make sure that they have a good experience. And some of the things you showed us here to allow us to detect and make sure that folks are having a great experience, I definitely want to dial into that application when we get ready to roll it out. We're still in a minimum viable product experimenting phase here. So
that would be great to see, and definitely keen to work with you on that.
Cool.
Getting that set up. Yeah.
Awesome. Very cool. I got a bunch of folks here in the chat room saying thank you so much for joining us, Jeremy. This is a great session. Thank you very much. Ancient Coder says thanks, Jeremy, and C# Fritz. Thanks so much, everybody, for joining us. This was great, and folks can get more about RayGun. There was a link that's been dropped here in the chat room for to try RayGun for free. There's a bit.ly link there. There's also a link here on Twitch just below the video. We're going to copy that link. We'll make sure that it's available with the YouTube video as well. If you're watching this on YouTube, you missed all the fun. Click that description link below and you'll see the link so you can learn more about RayGun and give it a try. And thanks so much, Jeremy, for joining us. This was great. Like I said, I've learned a lot, and I want to use this with our next application. And it kind of feeds in. I know you're working on, right? You've got JavaScript integration for crash reporting. I know you're working on some more stuff over there. I'd love to see this for Blazor, and that's got to be really interesting to do with right? My gosh,
I mean, I think I would guess that crash reporting would work well already. The challenge would be APM profiling. As I said, I'm not sure what the profiling APIs for Blazor are like. That's WebAssembly for
we're still early in the
may
preview.
not know the Blazor term.
Yeah,
but exciting. I mean, that space is a really exciting place.
Oh, it's growing and moving fast. And I want to call out all night long throughout the stream here tonight. Our sentiment analysis has been very, very high. Thank you, chat room. I'm glad to see that you've really enjoyed. The only times that it really dipped were when we said, "Hey, did anybody have a problem with this?" And you saw people say, "Yeah, I had a problem. I made a mistake. I made a thing." And you saw the sentiment dip. We're at 96% positive on the sentiment analysis. Thanks so much, chat room. That was really, really great. Look at the love going by. Thank you so much, chat room, for tuning in. Great stuff, says Dee.
Thanks, everyone.
Thank you. So here's what we do when we finish a stream here on Twitch, Jeremy. We set up, we send folks over to the next show, just like you would on radio. There's that bridge to send folks over to the next show. We're going to send folks over to our friend Talk to Me Guzman. So here's what we do. I'm going to issue the raid call. If you're a subscriber and you're hanging out there in chat, grab that first line of text that says, "The coding squad is here. All your base star belong to us." Copy that onto your clipboard. We're going to announce our presence when we get over to our next show. If you're not a subscriber, go ahead and grab that second line with the missiles, because we're going to announce ourselves in that next stream over there with Talk to Me Gooseman. So I'm going to set up the raid over to Talk to Me Gooseman. He's this is our friend Eric Guzman. He's working on an application with little Ruby on Rails. Make sure you check him out. Thanks so much, everybody, for joining us. And we'll head over there in just a few seconds. All right, everybody.
It's been fun. Thank you, everyone.
Oh, it was great. And make sure you check out RayGun at raygun.com. I'm going to be back again tomorrow morning, and we'll talk about We'll talk about some more stuff around Blazor and ASP.NET Core. All right, everybody. Thank you so much for joining us. We had a great time today. And let me just make sure this is all set up to go. There it goes. We'll see you next time. All right. Take care.